All right, welcome everyone. Thank you for joining us for today's group interview of the eVTOL Writers Group. I'm Jim Sherman and I'm the Director of Strategic Development at the Vertical Flight Society. For today's program, we have Bob Hammett, CEO of OneSky. And first we'll have a little bit of housekeeping before we get started. If you have questions during the presentation, please type them into the questions box in your GoToWebinar control panel. And we will have some time for questions at the end of the session, so please ask away. Our moderator today is Brian Garrett-Glaser. Brian is a reporter focused on UAM, or more recently known as AAM, as well as some other future-looking aspects of aerospace, including electric drive, hydrogen, UTM, and other important technologies to advance aviation. His work regularly appears on aviationtoday.com, and he has a newsletter called the Skyport, which is focused more specifically on UAM and eVTOLs, and that comes out every other week. So without further ado, I will turn it over to you, Brian.
Well, thank you very much. Thank you, Jim, and everyone at Vertical Flight Society for hosting these excellent discussions. Really appreciate it. And thank you, everybody, for showing up to listen in. I think this will be a fantastic presentation today. I'm really looking forward to it. And it's timed quite well, as there's a lot going on in the UTM space. And just about a week and a half ago, the FAA's Next Gen office put out a pretty interesting version 1.0 ConOps for UAM. So hopefully we'll talk about that a little bit as well. So without any further ado, I'll introduce our guest, Robert Hammett. Bob serves as the CEO of OneSky, which spun off from Analytical Graphics Inc., AGI, is headquartered in Exton, Pennsylvania, and Bob has senior leadership responsibility for development and delivery of innovative UTM and UAM software at OneSky, which was a pretty early entrance, I think, into the UTM space, as we were just talking about before we went live. So hopefully we'll hear more on that. Bob has more than 30 years of experience in the information technology industry, providing commercial off-the-shelf software and service solutions to government and commercial customers. Bob joined AGI in 2003 and has held business development, sales management, and business unit leadership positions. And prior to that, he spent 7 years with Parametric Technology Corporation. And prior to that, he was at Control Data Corporation. Bob also served 28 years on active and reserve duty in the military, retiring as a captain, and he served as a communications officer, operations department head aboard USS Nathaniel Greene, and later as an engineering duty officer and a new construction submarine project officer, and did 4 CO tours as a reserve. So I guess, oh, and you're also a drone pilot, which I think is very cool. So without any further ado, after that very long intro, I think we have about a 30-minute presentation coming up, so it should be pretty in-depth. And then after that, we'll have the latter half of the hour to go over questions. So thank you, everybody, for showing up. And Bob, over to you.
All right, thanks, Brian. Appreciate that quite long introduction there. So I do apologize for that. The story that isn't in there is that I joined the Navy to fly jets. My eyes went bad and ended up in submarines, because that I figured out that's probably like second best, second coolest thing to do. So that was it. So all right, let me go and see if I can share my screen here, and you should be seeing that. Does that look good?
Yep.
Okay, great. So, and thanks to Jim and the Vertical Flight Society. So we really appreciate the work that you're doing. As we looked at what was going on with the eVTOL and the push with urban air mobility, we realized that there's a lot of thought leadership coming out of Vertical Flight Society. So we've really enjoyed getting involved. We've loved the programming and the insights that are provided here, and certainly are appreciative of the opportunity to talk to the group today and keep the dialogue going, especially with everything that's going on, on in our world today. So yeah, so we'll go through here, give you a little bit of insight into OneSky, and then afterwards work through some questions. So okay, all right. So I don't know if who all is familiar with OneSky, but we really were created back in in the late 2014, 2015 time period to help address the new challenges that were envisioned for these new emerging players in the airspace. So, realizing that the current air traffic management system was not going to scale up to the volume of at that point UAS operations and then UAM operations, just given the state of the technology and the labor-intensive process there. We also realized that it wasn't going to scale down to the altitudes that UAS and UAM were going to be operating. We think about just core systems like communications, navigation, surveillance, were not going to be usable, especially in dense urban environments. And then the other piece was just realizing that the funding model was probably not going to be that FAA or CAAs globally are going to step up and write $1 million, tens of $1 million development contracts for folks to go out and build a UTM system. So at that point, we recognized there was an opportunity for our technology. We drew some parallels into some things that we were doing in the space domain, which are very aligned with UTM, and realized that there was an opportunity for us to build out this digital infrastructure, primarily focused on the beyond visual line of sight operations, realizing that that's really where the hard stuff was going to occur, and we're that much more appreciative and kind of that was further confirmed when the push for air taxis and urban air mobility kind of raised the bar, because now this really was manned aviation in these new airspaces. So that was kind of the origin of our efforts. As I said, that occurred back in 2015. We spun out of an organization called Analytical Graphics. So Analytical Graphics is a 30-year-old commercial software company to the aerospace and defense industry. They have about 50,000 users of their core product, which is called Systems Toolkit. It actually was previously called Satellite Toolkit, but then folks started applying it to many domains, and so we'll talk a little bit about the value that provides. And it really has become this global standard with well over 700 organizations taking advantage of its capabilities. So the good news there is that we came out of this organization instead of starting with an idea and an app. We started with 7 million lines of aerospace grade code that's been verified and validated and continues to get better every day. So our offices are actually on the 4th floor of the AGI building here in Exton, Pennsylvania. So there's 75 developers downstairs that are well, today they're not downstairs. Today, half of them are at home, but they're working, continue to raise the bar on that capability, and they were adapting the technology and applying it to the needs of UTM and urban air mobility. So at the core of the technology, what it really does is it does dynamic modeling and analysis, and so it can model essentially any platform, be that satellites, missiles, UAVs, aircraft, ground vehicles, any payload that's on board. So understanding the dynamics of the platform and the associated payload, and how to then optimize performance for that payload, as well as any operating environment that it's in. So land, sea, airspace. So the tool then is used to help in the kind of like the engineering V, if folks are familiar with that. Everything from design down through test, and then on through operations. So it truly does enable a digital twin of these complex systems that are being delivered today. And if you think about the IoT and where the systems are going, the complexities only increase at this point. And so there's a real nice tie into this set of mature capabilities. So I know this is a little bit of a busy chart here, and it actually kind of aligns to some of the charts that you'll see coming out of PK's group at NASA, and really addressing all the new airspace entrants that are kind of coming into the airspace that we need to share and harmonize the airspace with. And so the set of the three companies here are three different companies that AGI has spun out as we're addressing operational needs from ground all the way up to space. So that includes our sister companies, Cesium, and their geospatial technology, and also our sister company, ComSpock, or the Commercial Space Operations Center. So we'll take a look at what these organizations actually do. But the realization that we had when we looked at what ComSpock was doing in the area of space traffic management is that the ConOps is going to be very similar across all these different operations. So again, you've got to signal your intent, you've got to provide your mission plans, you've got to provide your maneuvers, your flight routes, and then you've got to provide operational updates. So the positional information as you're operating, and then notify when any issues or concerns arise. And so we've seen it within the space traffic management domain, and we're excited to apply the same foundation of technology and similar ConOps down in the UAV traffic management space. So when we think about the products that we actually bring to our customers in that design, test, operate cycle, it includes primarily five different capabilities. The first two are based off the AGI legacy products, the systems toolkit and the test and evaluation toolkit. And then the second two are our enterprise products for operations and UAV traffic management. And underlying all of it is a set of common core analytics. And these, again, are those proven analytics that have been developed, enhanced, improved, optimized over 30 years, and continue to kind of get better every day. So that's the set that we bring to the market. Customers, depending on the market and their maturities, customers can enter at any point, kind of in that depending on where they're at with their systems, and we've got ways to help them, and then kind of continue to reduce risk for them as they move toward operations. Because in the end, if we're not getting to operations, we're not going to enable the kind of the business models and the good that's possible from these new platforms. So those are the technologies. So we'll give you just a little bit of an overview of them, and kind of let you see how they operate and what they do. So so you'll see that the technology we have is very graphic intensive here, because we're displaying everything that we do in 4 dimensions, because we've recognized that while we can do some phenomenal analytics, if people can't understand it, if they can't really see it, they just don't quite get what's going on here. And so, or they may not get what's going on. So complex concepts become a lot easier to understand leveraging technology like this. So again, modeling any of these platforms, the payloads that are on board, the operating environment that they're in, whether it's terrain, building, core capabilities like communication, navigation, surveillance, so that we can understand the systems, predict what they're going to do, look at future systems, understand how they're going to impact the safety of operations and the safety of the airspace. So do the modeling, we do the analysis for systems performance, trade studies, and can integrate other tools in as well, whatever these customers need, with, again, this very rich output there. So so these are just all pictures of the kind of screenshots of the technology. And then when we move into the urban air mobility or advanced air mobility domain, you think of the opportunities. You think Brian had mentioned the ConOps. Well, you can put the ConOps down in a document, or you can actually model it in 4 dimensions. You can model what a UAM corridor looks like. You can model how the aerodromes are positioned, and what the routes might look like coming in and out of there. You can scale up the number of operations, and then figure out, when they talk about tracks, what are these additional tracks going to look like, and how we're going to manage those. And then you can model nominal and off nominal operations, and kind of work through what that looks like, and then share it with all the stakeholders, get them involved, get them to understand how these things are going to operate, so that so local communities, they understand visually what's going to happen, what's the noise profile going to look like, and so they can start figuring out how to integrate them into their neighborhoods. So this is just again the core systems toolkit, or we call it the urban air mobility toolkit capability. Let's move down to the next one, and then within that, even down at the subsystem level, then you can take a look at, hey, do I have my communications challenges solved? Do I have my navigation accuracy? Do I have some sort of a surveillance radar, detect and avoid? With urban air mobility, you'd have the pilot and command initially, but as we move to greater automation and greater autonomy, how do we envision those systems working? What are the inputs that they're going to have? And let's go ahead and prove these things out in a virtual sense before we then have to move to building prototypes and operational vehicles. So again, rich capabilities here to perform that analysis, and then even scaling that up into further trade studies. So it could be trade studies to understand routing for passengers, for delivery, any different business model that we'd like to. So it can be not only real time, but accelerated and full scale simulation for anticipated future operations. And then as a result of this modeling, simulation, and analysis that we do, we can then get these very, very rich set of deliverables that can be taken advantage of to do any number of things, from interfacing internally with your organizations, interfacing with customers, and interfacing with regulators, getting waivers, safety approvals, and as we said, integrating with the community for building up of community adoption. So lots of great uses that come out of that. Another key aspect that we see the industry needing to address is platform certification. And so this is an area that we have been involved very heavily on the military side, and we actually implemented or developed a capability called the Test and Evaluation Toolkit, which was really geared toward the flight test practitioners. And so the flight test engineers, the folks that are actually accomplishing the validation of system capability for these manned military vehicles. And so we actually started with F-35 probably about 8-10 years ago, and have expanded really to every new and many legacy platform in the Air Force and the Navy arsenal there. So just a couple of examples of the folks that are relying on this technology. And again, it's flight tests can be very challenging. Access to ranges can be very limited. When you get there, you want to get the data that you need and get it done on time and get out. And so in working with them, we can do better prediction of system performance, and let them achieve what's called higher test point density. So when I fly, I get as much data as absolutely possible, and I eliminate some of the mistakes that just happen because of the complexities of test and evaluation. And so not only test point density, but reducing the refly rate, because the refly rate for some of these flights can be in excess of 35%. And if it's a multi-ship F-35 flight against aggressor aircraft, that can be a million two day at the range, and you certainly don't want to mess that up. And then post-flight in an urban environment, and kind of taking a look at what the data would look like there. And so this could be analysis of cellular signals in a dense urban environment, and making those assessments and ensuring that you're going to have the communication assurance that is required for safe operation. So let me move on to some of the enterprise applications here. And so first thing I wanted to highlight, I had mentioned our Commercial Space Operations Center. And so this was established and went operational about 8 years ago. And what our ComSpot does, it was actually first created to provide air traffic management for the geostationary satellite operators. And so there's a group out there called the Space Data Association. They all realized as a community that they needed to better collaborate on their operations to prevent any potential conjunctions up at geostationary orbit, where one accident could really wipe out that whole regime there. And they also realized that they were getting interferences, and most of these are communications satellites, and so they needed to find better ways to communicate back and forth when those occurred. And so what they did is they selected the AGI as their CTO, and we built something called the Space Data Center, where we act as that kind of neutral third party. They provide us with their operating plans, their maneuver plans, and their real-time information as far as satellite positions. And we bring that in and we aggregate it, we deconflict it against all the other operations that are going on in space, as well as any debris that might be out there as well. So there's a lot of non-cooperatives in space, which could be everything from rocket bodies down to little pieces and bolts from disintegrating aircraft or satellites. And so we bring that together and perform that function for them. And again, the concept of operations is very similar to UTM. We just need to kind of scale down the altitude. So we had seen the value this provided to this community, and so we recognized that we had the raw tools and the raw capability, then apply that to UAV traffic management. So, and if everyone is ever in the Exton area, certainly welcome you to stop on in. It is literally right kind of behind the wall back here, and you can come and see the CommSpock system in action. And then we've gone on to deploy air operations centers for other groups within the Air Force, whether it's the Joint Air and Space Operations Center, or this example here is for one of the largest delivery organizations in the world, and this is Air Mobility Command out at Scott Air Force Base in Illinois. And so we provide that core situation awareness and decision support capability for them to conduct global operations with a variety of different air vehicles. And then the effort with OneSky has then been to adapt these capabilities and really get them dialed in to meet the needs of the emerging requirements of UAV traffic management. And as we look at that, we envision this growing to encompass many different participants, whether on the operator side or on the coordinator side, as the whole UAS ecosystem grows, and as we connect more and more of the infrastructure together so that we can safely enable these new operators to join the airspace. So again, we've been involved with a number of the tests from the NASA TCL4 activities and advancing those efforts, working with several of the FAA test ranges. So we've been able to work kind of side by side with the other USSs or the UTM software providers, and jointly testing our systems, and then even providing additional capabilities. Like one capability we have is a supplemental data service provider, an SDSP, for to let everyone share a common altitude reference system. So this is just one of the challenges that you find when you bring all these systems together. You didn't have standards in place. They're sometimes on the space side, they're in different coordinate systems and reference frames. So we've got the ability to bring that into a kind of a neutral set and share that information. So involved with the national campaign, and looking forward to what that's going to mean to the understanding of UAM ConOps, and advancing from 1.0 to 2.0, and really moving that in the right direction. And then we've been involved over in Singapore, and really got started with some initial demos over there back in late 2017 and 2018, and then this resulted in an agreement or a contract that we have with our partners over there, Nova Systems, Scout Aerial, local cellular provider M1, even Amazon is participating in this, and this is a system which we'll be demonstrating in September this year. Hopefully September if we're able to travel over there. But again, advancing the thinking, addressing it in a dense urban environment, and really helping folks understand what it's going to take to safely enable these sorts of operations. So a lot of these videos are actually also available online. So we'll send out some links. We work with Brian and Jim on that, so you can view those in case we didn't get to see them in their full extent. So it wouldn't be Singapore if you didn't get the obligatory picture of operations by Marina Bay Sands. So here we're doing testing downtown, and well, at least down by the marina, and it was actually, it's quite interesting when we go out in these urban environments. 90% plus of the folks are really intrigued and excited about what you're doing, and the value that it can provide, and just curious about how this is going to impact their lives, and hopefully provide kind of good services for the community. So I think that is about it. So this is just a picture of the team at AUVSI Exponential, and all the companies that are leveraging this same core set of technology that we're leveraging here. So so as I said, it's well proven, has been solving mission critical, life on the line types of challenges, and we look forward to continue to evolve it to address the needs within the UAS and the UAM space. All right.
Fantastic. Well, thank you very much, Bob. That was fantastic. That was very, very interesting. I've got a million questions written down, but I really want to make sure that everybody else gets their questions in as well. So I'm going to start off with one or two of mine while I give everyone else a chance to go ahead and submit what they're most curious about. So I guess I'll try to start a little general. Could you talk a little bit about what needs to happen in between today and this future UTM system that we all would love to see in action? There's a number of, I think, regulatory things that need to happen, probably some tech things that need to happen, and maybe infrastructure development as well. Could you talk a little bit about what all the barriers are between now and then?
Sure. Yeah, and it has been a very interesting journey, as we said, since that 2015 time period. And I think when we all started this, we thought we'd be a lot further along than we are today. But there are no lack of complexities. And as you said, some of them are technical, some are regulatory. It's getting everyone on the same page, and ideally we'd like to see that via standards and regulations could be adopted on a global basis, so that we've got better harmonization, better ability to leverage the business model and the technology outside of just one country or just one region. And so at the core of that, there's as we talked about, the regulatory pieces. And so you see whether it's the FAA or you see the U-Space efforts in Europe, working through the different technical challenges. So working through things like LAANC, so low altitude authorization and notification capability, which is kind of like a early version of what a basic UTM capabilities for the line of sight operators, to now moving on to address things like remote identification. And so we're on a cohort with 8 companies, including Amazon and Wing and Intel and Verizon and AirMap, just looking to solve that challenge. And what we're seeing is an openness by the FAA to consider the industry consensus standards, which is really important, right? Because that gives industry an opportunity to get involved with organizations like ASTM or ISO or whichever the groups are that are helping put these together, and advance the thinking, so that as we move to things like urban air mobility, and we talked about the UAM ConOps, they talk about things like community-based regulations, right? Or is that community-based rules, which is the same thing. It's getting the standards organizations together and having them help with the regulators figure out what needs to occur here. So all the stakeholders can have a piece in that. And then then it's just, as you said, the infrastructural pieces, right? We've talked about communication, navigation, surveillance. How do I solve the surveillance problem? Is it with the detect and avoid? Is it with other technologies? And how do I move those forward? So I think there's a number of different technologies being proposed in each of those different areas, and we're working with operators, we're working with CAAs to help them assess what those best solutions are, and come up with some recommendations.
You mentioned working with standards organizations. One of the questions that came in is, what organizations are you working with on standards development?
Yeah, so one that's really that's been very prevalent in this area, and actually is literally right down the road from us here, is ASTM. So they've shown excellent leadership with the F-38 group, and certainly the remote ID standard is getting a lot of traction and a lot of interest globally, and so you can envision that very much of that will get rolled into regulation at some point. So those are just examples of one organizations, but there's the ISOs, there's Experimental Aircraft Association, I think, has gotten involved with air vehicle certification and Mosaic. So there's just a number of standards. One organization that we get involved with, which isn't kind of standards based, but it is a community. It's an association, would be the Global UTM Association. And so we've got a lot of the organizations that we've been working with from the very beginning. They're in some sense competitors, but we're also kind of on this same journey together, and we work together to try to advance our understanding of what's possible, and then help educate regulators and operators on that, so that we can hopefully accelerate that industry. And they reach out and get involved with other industry organizations like GSMA as we start to think about, hey, is our technologies like cellular a capability that should be taken advantage of as part of that communication capability. So a lot of opportunities for folks to get involved, and a lot of good work going on there.
That last bit that you mentioned, is that still an open question, whether or not cellular should be used?
I think, well, there's lots of folks with lots of different ideas, right? And everyone has a different horse in the race. And so, sure, you're going to have everything from cellular to satellite communications to any dedicated spectrum being thrown out. There's opportunities for assured C2.
Mm-hmm.
Yep.
Talking a little bit more about infrastructure and capabilities and enabling the type of operations that we're talking about here, I think that the how should I put this? The level of capabilities needed is probably dependent on the operation, right? So the capabilities that you need for a drone flying not particularly over people, not BVLOS, is very different from drones flying in urban areas, is also very different from passenger carrying UAM. So I wonder if you might talk a little bit about how OneSky sees that, and where a lot of maybe US cities are today compared to what the bar probably will be for what capabilities need to exist to enable these services.
Yeah, that's a good question, and assessing the risk is really a broad category, and one that has we've kind of seen different efforts and initiative go through here. So we've seen folks like Sora, which was a great independent group coming from JARIS that was doing assessments for the ground-based risk and the air-based risk. And as you said, it really there's so much of the risk is specific to that operation, to that where the services are being provided or the operations are flying. So there's ways to mitigate and manage that risk by controlling many of those factors. And so all of these can be brought in the equation to ensure that we can let these vehicles operate safely in the airspace. So it's an area that we continue to follow. We continue to look for where the the standards are going to be then adopted as regulations and incorporate those. So yeah, it's a moving target. Now again, as I said, when we saw things go toward the air taxi market taking off and urban air mobility, the realization there is that this is manned aviation here, and so you know what the standards are there, right? So that there aren't any changes or compromises there, and I don't think you'd expect that of your regulator to be compromising safety for those.
Mm-hmm. One question that comes in, you mentioned Singapore. What other countries are you working with toward providing UTM services or other related services for unmanned aircraft?
Yes, that's a good question. Some of it is commercially sensitive, but we do have a global distribution network of resellers, again through our relationship with AGI, and so we do have active efforts and engagements in Europe, the Middle East, the Asia region. So just kind of really all over. I certainly think that the effort that we're involved with in Australia is kind of at the forefront of that. You can also look and you can see great open efforts internationally at organizations like Swiss FOCA and the SUSI effort. Urban air mobility, you see efforts like what's going on in Toulouse and what they're doing there to try to bring urban air mobility and just urban mobility to that region.
To ask a question about that last one, I know Toulouse has a pretty big project underway to try to evaluate, and lay the groundwork for UAM. Can you talk about, given the stage that we're at currently, what kind of, I don't know if you can share much on this, but what kind of services or involvement would you have with a city like Toulouse, or Toulouse specifically? What type of services is OneSky providing at this stage?
Well, so I mean, what we are finding is that cities have the need to kind of take that conceptual ConOps 1.0 and figure out, how do I then wire that to my city, right? What is my real infrastructure, and where are my opportunities to operate and take advantage of these corridors? Where do I have the demand to move people, within the city? And our ability to quickly and easily model that in a desktop type of environment, and let people iterate on it, think about it, communicate, share it is really the first step, because you've got to figure that out, because that goes into, hey, what do you have? What do you need? What's the business model going to be? And are you solving a mobility challenge here? So
right. Yeah. So once you've got sort of the part of the equation that the city would provide, saying, here's the people we have, here's where they want to go, here's what the demand is, et cetera. What else would you layer on top of that to then figure out where to, install corridors or that kind of thing? I mean, are we talking about like cellular coverage analysis? What would you name as the most important pieces of the puzzle here to help cities understand where to path this out?
Yeah, so cellular and communication is obviously critical. Since these early operations will have a pilot in command, you've kind of solved part of the surveillance piece there, but I think they also need cities also need to understand, hey, where are my citizens going to feel comfortable having these things flying? And so being able to take a look at what are the routes, what are what are the risk factors under and around those routes, and then what are the alternates when I've got an issue or a challenge. And so being able to bring that in and looking at those risks over time, because the ground-based risk changes as you've got seasonal changes, as you've got festivals and concerts and other activities that are going on in there, and so all of that can be factored in and modeled and assessed. So yeah, getting the corridors right. We've done a lot of work with noise modeling for DARPA, and so bringing that sort of analysis in and understanding what's that noise footprint going to be, and what's that going to mean to folks, and are we going to have key nodes that have kind of just noise saturation, that's just not going to be acceptable, and how do we work around that? So yeah, I think everyone has to kind of internalize and start to kind of wire this up in their own cities to understand what their needs are.
Mhm. Speaking of commercially sensitive, can you tell us anything about companies in the UAM space that you're working with, OEMs, anything like that? And if you can't name names, could you tell us anything about what types of services at this point?
So we are working with folks in this space. We're helping them kind of understand, first off, just the business model aspect of it, and wiring in demand generation and capacity modeling capabilities, and then figuring out what those routes would look like and what those operations would look like, and then they can continue on with the models to then assess, hey, what's this really going to cost, and then what's that come down to cost for the passengers there. So that's one area that's very key. The other opportunity is certainly on the cargo side, and kind of taking these same vehicles and using them to solve some of the larger cargo issues as well. And so there's interesting opportunities there as well. And so helping folks understand that, model it, and then realize that there's certain analytics and certain capabilities that we can start working with them in the ConOp side, and they've got that access that same capability all the way through to operations.
Gotcha. And similarly, what role is OneSky playing in the NASA AAM program, if you could tell us about that?
So we're one of the Aerospace participants in the AAM program. So that we envision that will be very much like the NASA UTM effort, and the TCL type of a process, technical capability levels, as we went from one set of demos to the next, to better inform and actually test out real-time operations. And so we see the same thing going forward with I always get the names, with the Grand Challenge and now the National Campaign, and
Right.
NASA helping to kind of lead that in understanding and defining what those requirements are going to be. And so I think the good thing about NASA, it's very open. They're encouraging participation from a lot of different organizations, and we're working side by side with other aerospace providers as well as the other platform providers, and look forward to seeing where that goes, and hoping that we can go as fast as we can, right? Because the investments to participate in these are not insignificant, and we really need to show that there's viable business models out here, whether it's on the UTM side, whether it's on the UAM side. So that's that's another area of challenge that at least our segment of the industry faces, and people have had some cutbacks, but we're hoping that we'll be expanding operations soon.
Right. And speaking of NASA and all those programs, if you have any better name or acronym suggestions, we'll take them, I think.
Yeah.
So one question that came in, I think we talked about this a little bit, but maybe there's other areas to explore. Where are we in the US in terms of deploying the more advanced functions of UTM demonstrated in the TCL demos? We talked about this a little bit, and I don't want to ask you to make regulatory forecasts, as none of us have the answers there. But do you think there's any other areas to talk about there?
Well, as I mentioned, we are part of the remote ID cohort, and so we do see that as being just a critical piece for not only for FAA but for other government agencies who just had to have an appreciation and understanding for what are the operations that are out there. So you think about the security concerns associated with with commercial operations, and so remote ID will help address that. And so that is kind of that next major piece that we're looking forward to having completed. That then ideally very quickly followed by operations over people, and then beyond visual line of sight, which then kind of opens up the marketplace to a lot more interesting operations.
Right. Pulling on that thread a little bit, I want to ask you about counter UAS. I saw it appear on one of your last slides a little bit, but can you talk about how that incorporates, or how that is part of what OneSky envisions doing, and how that ties into UTM? Do you have capabilities to pick up non-cooperative drones? and identify them as part of your offerings? What are you doing in the counter UAS space, and how does that play into UTM?
Yeah, that's a great question. And so actually, to understand who the unauthorized operators are, you need to understand who the authorized operators are, and then you need some means of surveillance. And so there's a lot of great companies that are out there developing surveillance solutions. Whether it's via signals, radar, whatever sources. We've in our Commercial Space Operations Center, we work with any number of external sensors that we bring in to add additional insight into our operations and identify some of these non-cooperative operators, and have literally identified some interesting nefarious operations by other countries in space. And so it's the same concept here. So we've got to bring the authorized operators in, pull them out of the picture, and then see what's left in the data, and then figure out how we isolate and assess the risk of those operations.
Mm-hmm. I also noticed something toward the beginning of your presentation about funding models. At the beginning, you sort of laid the groundwork for your presentation by saying, ATM can't scale, air traffic management can't scale to where we want it to be, and these are that's one of the main drivers for the creation of something like UTM, but also that the funding model of traditional air traffic management isn't going to work for what we all want to see here. So I was hoping to ask you about that a little bit. Really the question is, what will the funding model be, or what will the charging model be, and how will that play into the cost for things like air taxis, as all these companies are looking to provide services that are not incredibly expensive, and I think we're all hoping to ride in them for less than our entire paycheck.
Right. Yeah, that's a good question. And so we have to look at what's going on, in similar markets. And if you looked at manned aviation and the way air navigation service providers pay for the systems and the services they provide, they have a set of rates, and it's a per kilometer fee that these operators are paying for different services, and then they're paying for additional fees for landings and takeoffs, and so kind of aggregating and adding those up, so they're paying directly for the services that are being provided. And so when you take a look at then the parallel on the UTM side is there are going to be some basic USS services, or for urban air mobility, PSU services, and then there's supplemental data services that might be provided. And so there'll be a number of different contributors that are required to enable that safe and efficient end-to-end mission. And so we're going to have to work those out. We realize that the good and the value that's created by delivering these services will need to cover the cost of implementing the systems, as any business model would for any new capability or products. So.
Sure. Can you give any sort of ballpark figure of what you think it might cost for a company to fly a taxi across the city using a OneSky service?
I actually can't, but I can point you to some business models that we've seen on the UTM side, and one would be out of Italy, where the NSP there proposed a $1 per hour fee for the basic UTM services. And so that's there'll certainly be a lot more drones than there will be air taxis, and so maybe they're going to make it up in volume on that side, but at that amount it does scale pretty quickly.
Got it. Okay, we've got a question or two coming in about UTM to ATM. So the question that came in here is, have you begun working with NASA on applying the principles of UTM to ATM, which NASA is calling XTM? And we'll start with that, and then maybe we can go further into it.
Yeah, certainly it's an area that we envision getting more and more involved. So you really have this excellent ecosystem to test automated ATM in this UTM environment. And so you can think by proving that out, proving the safety of it, continue to improve that, continue to increase the autonomy in that, introduction of AI systems to make these better and better in a lower risk this isn't manned aviation environment, provides the ability to prove these things out, and then hopefully find other altitudes that we can apply these to. So sure, you see it coming together as we start working with these new airspace entrants at all these different altitudes, and UTM is kind of the perfect place to get started.
Mm-hmm. So maybe that's a good pivot point into talking about the UAM ConOps that the FAA put out recently. So this is their version 1.0 description of how UAM corridors are going to be established. It seems like the FAA is mostly just sort of offloading the responsibility for creating and governing these corridors and figuring out how the permissions and restrictions will evolve over time, pretty much just offloading that to the community of companies that are running the system. Would you say, first of all, would you say that that's an accurate description of it, and what's your general sort of reaction to it?
Well, it certainly does seem like they're open to it, right? When they talk about a demarcation line, and a demarcation line, on this side, they're providing the services, and then in this new airspace, in this new UAM corridor, that this is going to be provided by the commercial entities. And so, yeah, I think it's a very interesting and exciting concept, and it gives industry the opportunity to have a clear impact and driving those technologies that are going to enable that safe operation in that airspace.
Gotcha. So what do you think about the ConOps in general?
It's excellent. The hardest thing has to be putting that first one out, right? And putting a stake in the ground and saying, here it is. This is our best thinking right now, and we're all going to learn from here, right? And so, it's good for that to occur here. It's good for that to other participants to come up with their ConOps. I've seen Airbus, Embraer, different ConOps getting out there so that we're advancing the dialogue and advancing the discussion, and then trying to prove out some of this with exercises like the national campaign. So yeah, so I think it's a great start. Kind of helps align thinking and identify where thinking isn't aligned, so we can do more work and hopefully get to an operational state.
Yeah, I'm just going to echo what the Vertical Flight Society just posted in the chat, which is we've got a couple minutes left for questions. So if you've got anything to ask Bob from OneSky, please take your opportunity to throw questions in there. One that I haven't addressed yet is how will microclimate weather forecasting be integrated into the system?
Yeah, so I mean, weather is another one of those supplemental data services that needs to be brought in. It's for for UTM, for UAM, and there's a number of excellent companies out there that are preparing to provide those services or starting to provide those services today. So obviously these vehicles can be significantly impacted by local weather in urban environments, and so we need to understand that and account for that in their operations.
Mm-hmm. I wonder as well if I could ask you about, and this could apply to weather, but I think cell service and a variety of other things. I wonder about the density of systems that is needed to achieve the reliability that we need. And I guess in part this question can't really be answered until standards are developed and the FAA makes rulings that it needs to make on reliability and risk tolerance and that sort of thing. But I guess what I'm trying to ask is, if you look at a city, and you think about the various types of sensors and radars that you would need placed around the city to enable UTM, I mean, what kind of density do you need those systems to be at in order to achieve the reliability that we need?
Yeah, it's pretty interesting when you envision what this urban environment might look like, and what are those sets of sensors that could feed not only urban air mobility, but all sorts of ground-based mobility, all sorts of different operations in the city, and all sorts of kind of new businesses that could take advantage of it. And so, I mean, we're working with companies on things like resilient position navigation timing to different communication opportunities and systems to the detect and avoid piece, the surveillance pieces. I mean, that's a big challenging one. And so, you know, are they onboard systems that are more cost effective, or are you really going to be able to you know, place radars throughout a city, and what's the cost, feasibility, and maintainability of something like that? So
yeah. Can I press you on that final point, because I think you asked a very good question there, and I'd like to know what you think about it. For, onboard versus ground, and then I guess there's probably communications concerns as well. We had an interview with Wisk recently, the Kitty Hawk Boeing joint venture, in which the CTO and the CEO said that they were, out of the many areas that need a lot of technological improvements to make this happen, both, you know, on the aircraft platform and on the UTM side, communications was not one of them. They were not really concerned about making it work, and there was not a lot of bandwidth, they said, was required for their vision of how this was going to work out. But I've also talked to some people who say, you know, that really depends on where a lot of the processing is getting done, right? So if you've got onboard systems that are, for example, doing the video processing and the detect and avoid, then you need to bounce, you know, megabits of data back and forth ground systems, and you don't need a lot of bandwidth. So this is a long-winded way of getting back to exactly what you said at the end of your last comments.
Yep.
What do you think about all that, on board versus ground, et cetera?
Yeah, that's again one of the many system challenges that needs to be addressed. And so I really I don't think I've got the insights that an operator would, as far as how they're planning on doing that. I do think that the onboard systems have some nice advantages. But you know, it's going to be you know, as we even talked through UTM, it's certainly going to be a layered approach, right, to ensure the level of safety. And so we'll continue to work with companies to assess the alternatives, and you know, as new creative ideas come up, the good news is we're able to put it in the system and you know, model the sensors, model the data connectivity required to you know, to satisfying the compute that's required. So all can be modeled and assessed up front.
Understood. Okay, then the one last question that I haven't asked yet is kind of on the insurance side, but you might have an interesting perspective here. Just like current commercial operators, you know, airlines have insurance, et cetera. All operators have insurance. Have insurance companies weighed in on their position on the risk?
Oh, that's a good question. So yeah, we have seen, you know, just on the drone side, so you've seen the different insurance organizations that'll provide insurance on an individual flight basis, but I would envision that they will be very active as we move toward you know, toward operations. And again, when we think about the parallels in with our space traffic management system, the folks that are very concerned about the safety up there, besides the operators, are the insurance companies. And so they've been very interested in understanding what is the safety blanket that a space traffic management system provides, and what does that then mean to, you know, to my insured assets. So, you know, the same thing is going to you know, is going to occur in the other layers of airspace operations. And so yeah, for air taxis, that will, you know, certainly again, you've got adjacency of you know, manned helicopters and operations there, but you're going to have to make new parallels with the new equipage, the new capabilities, the new redundancy, and you know, what does all that mean to safety?
Right. I don't know if this is still their plan, but I remember at one point Uber was talking about landing Uber Eats delivery drones on delivery drivers' cars on top of the car to have them go deliver, you know, do the last mile delivery or something like that. I would be very curious to know what insurance companies would have to say about that.
You like the creativity, right?
Right, yeah. Well, we're just about out of time here. So thank you, Bob, very much for tackling all the questions. Greatly appreciate it. Thanks everybody for tuning in. And I guess I'll throw it over to Jim in case he's got any last words for us.
Thanks, Brian.
Great, outstanding. Thank you, Bob, for taking time out today. We really appreciate it. It was a great presentation. I definitely learned a lot. And Brian, thank you for moderating a great presentation and a good Q&A session. So we have reached the end of our program for today. So I just want to remind you that we do these interviews about once a month, and we have some good ones in the works for planning for next month and further out. And we will share those with you as soon as we get some confirmations on dates and so on. Another reminder that we do some other virtual programming, including the Electric Aircraft Symposium, which is coming up July 28th through the 30th, as well as our Progress Toward Autonomous Vertical Flight webinar on August 10th, and registration will open for that shortly. So with that, I thank you for your time and your support, and we'll catch you on the next program. So enjoy the rest of your week, and we'll talk to you again soon. Bye now.